I need to tell you about an incredible cosmic mystery unfolding right now. NASA has just released amazing news about a comet from beyond our solar system named 3I Atlas. And what we're seeing is baffling scientists. This isn't just any space rock, it's a cosmic rebel. Imagine a traveler from another star passing through our neighborhood, but 3I Atlas is behaving in a way that defies all expectation. It's still incredibly active, still glowing brightly, putting on a show long after it should have quieted down. It should be fading, disappearing back into the darkness. Instead, it's doing the exact opposite. It's vibrant, sending signals of continued life. This unexpected drama is both fascinating and a little unnerving. To truly understand why this is astounding, let's first look at what a normal comet usually does. Knowing the cosmic rules helps us see how much 3I Atlas is breaking them. Picture a typical comet, a frozen wanderer from the outer reaches of our solar system. As it swings closer to the blazing sun, a predictable cosmic dance begins. The sun's fierce heat starts to warm the comet's icy surface. This ice, a mix of frozen water and gases, doesn't melt. Instead, it turns directly into gas, a process called sublimation. This escaping gas, carrying tiny dust particles, forms a giant shimmering cloud around the comet's core, which we call the coma. From this coma, a spectacular long tail stretches millions of miles, pushed by the solar wind. The closest point to the sun is perihelion. This is the peak of its performance. The sun's radiation blasts the comet, turning it into a cosmic geyser. Gas and dust erupt massively, making the comet shine its brightest, a true celestial beacon. But then, after this dazzling peak, the comet begins its long journey back into the cold, dark depths of space. This is when the predictable happens. Like a stage curtain slowly closing, the comet's show is supposed to wind down. Less heat means less gas, so the brilliant coma shrinks. The long tail fades, and the whole performance gradually quiets until the comet becomes a dark, silent rock, drifting away. This is the script, the expected path for almost every comet we observe. But 3I Atlas, our mysterious visitor, completely ignores this script. It passed perihelion weeks ago. By now, based on its distance from the sun, it should be noticeably dimmer. Its brightness should be dropping steadily, gas production falling, and everything winding down. Yet, when astronomers compared recent brightness, something astonishing appeared. The comet hasn't dimmed as it should have. While slightly fainter than its absolute peak, the drop is far too small for its current distance. If you look at the predicted brightness curve, how bright a comet should be at different distances, and compare it to 3I Atlas's actual brightness, they match well at first. But right after perihelion, the real measurements completely diverge. The expected curve drops smoothly, but the actual brightness of 3I Atlas simply stays flat. It's like the comet decided to do its own thing. This means 3I Atlas is still furiously pumping out gas and dust at a rate usually seen much closer to the sun, acting as if it's still being intensely cooked, even though it's moving away. You might think perhaps it's just leftover glow, old material slowly dissipating in the coma. This could explain high brightness, right? But the latest images completely prove that wrong. When astronomers took deep, stacked exposures to reveal faint details, they didn't see a quietly fading coma. They saw active structure, distinct layers. The coma is being actively fed by fresh material. You can actually see multiple shells in the inner coma. These are faint arcs of gas and dust, nested like tree rings. Each shell represents a pulse of activity, a fresh burst of gas escaping the nucleus. The outer shells match earlier known bursts. But there's a new inner shell that wasn't there before, it just appeared. This means at least one new burst happened recently, not weeks ago, near the sun. At a time when things should be calming down, when 3I Atlas should be getting quieter, it instead had another outburst. It unleashed another wave of gas and dust, continuing its defiance. And its magnificent tail tells the same story. Instead of shrinking into a thin, lazy streamer, the tail is still crisp and defined. In fact, latest images show a sharper, more defined spine, a bright central line of dust running right down its middle. This is exactly what you'd expect from an active jet, a vent on the nucleus still firing, refusing to switch off. Visually, 3I Atlas is clearly declaring, "I'm not done yet." Now let's look at the hard numbers, the actual measurements behind this alert, because this is truly fascinating. Latest estimates of how much gas and dust 3I Atlas is throwing off, its production rates, are not sliding down a smooth ramp towards zero. They plateau, leveling off. In some specific light wavelengths, they even bump slightly upward. This isn't how a cooling, fading comet behaves. The spectral lines, like cosmic fingerprints telling us what gases are present, are still strong. Especially prominent are lines from stubborn gases, those taking longer to heat up and vaporize. These show up loud and clear in the data. And the ratio between different gas types has shifted again, telling us the chemical makeup of what's erupting is changing. The inner coma is now rich with fresh dust that wasn't there before. This is a crucial clue that it's not just surface material from perihelion. This is deeper material. Layers further down inside the nucleus are still being heated, still reaching their vaporization temperature, still turning into gas and escaping. But here's the most telling and truly amazing part of today's alert. It's found within the comet's orbit solution. Every time new position data arrives, NASA teams update the comet's path, where it's been, where it is, and where it's going. To make these calculations super accurate, they must account for non-gravitational forces. Most space objects, like asteroids, are just rocks. Gravity from the sun and planets is the only thing moving them. But comets are different. When a comet actively vents gas, those jets act like tiny rocket thrusters. The gas shooting out pushes the nucleus in the opposite direction. Newton's third law. These small pushes add up, actually changing the comet's trajectory in measurable ways. So in orbital calculations, there are non-gravitational terms, extra accelerations that account for these jet pushes. If 3I Atlas were calming down, if its jets were shutting off, these non-gravitational terms should be shrinking. The comet should act more like a dead rock, driven almost entirely by gravity with less push from its jets. But new calculations show the opposite. The strength of this non-gravitational acceleration hasn't collapsed. It's holding steady in some directions, even slightly stronger than before. This means the jets are still firing. The comet is still pushing itself around, still steering itself with these gas vents weeks after perihelion when it should be shutting down. So let's bring all these incredible observations together. The brightness isn't dropping as expected. The coma is growing new shells. The tail remains sharp and defined. The gas mixture is constantly changing. And the non-gravitational acceleration, the jet activity, has not gone away. This is why NASA issued the alert. 3I Atlas is still active, and it truly shouldn't be. So what does this actually mean? What cosmic processes are happening inside this mysterious object? To understand this, we need to think about how heat travels through a comet's core, its nucleus. It's not like heating a solid rock in an oven where everything warms up evenly. Comets aren't solid chunks. They are porous, full of tiny holes. They are layered like an onion and filled with pockets and empty spaces. They are a jumbled mix of ice, frozen gases, dust, and rock. When 3I Atlas was close to the sun, its surface heated up first. The sun's radiation warmed the outer layers, and those ices started vaporizing. This gave us the wild early activity and the big outbursts and bright flashes seen near perihelion. But heat doesn't stop at the surface. It slowly conducts inward, migrating down into deeper layers. This is not a fast process. It takes time. So right now, even though the comet is farther from the sun and its surface is cooling, a slow heat wave is still moving through its interior. It's reaching pockets of ice deeper down that haven't been touched yet. Some of these ice pockets have been sitting in the dark for billions of years, frozen since the comet first formed. Perhaps in another star system, even before our own solar system existed. And now, for the first time in eons, they are finally getting warm. When these deep pockets finally reach their threshold temperature, when they get hot enough to vaporize, they don't care that the comet is moving away from the sun or that it's supposed to calm down. They vent anyway. The ice turns to gas, which pushes its way up through cracks and fractures in the layers above, bursting out at the surface. This is why the activity curve has these bumps instead of a smooth decline. Each bump is a new layer waking up, a pocket of ice reaching its vaporization point, and each time, it's not just the same gas. It's gas from a different spot inside the nucleus, from a pocket under different pressure, with a different chemical makeup finding a new route to the surface. New fractures open, old ones widen, the balance of different vents shifts. From the outside we see the results: new shells in the coma, new structure in the tail, brightness patterns that defy expectations, and a non-gravitational acceleration that refuses to disappear. But from the comet's perspective, it's simpler. It's still changing, still evolving. Its deep layers are still waking up, revealing ancient secrets. And this is where this alert truly matters. An active comet isn't just bright and interesting. It's under constant, immense stress. As gas pushes through cracks, it exerts force on the surrounding material. When jets fire from off-center spots on the nucleus, they create torque, twisting the nucleus. If the comet's rotation changes due to this jet activity, that shifting spin pulls on weak regions, creating stress patterns. We've seen comets in our own solar system follow this exact path. They stay active, even when they should be calming down. Then one day, they are no longer a single nucleus, they are a string of fragments. The stress was too much. Something gave way, a fracture spread, and the comet broke apart. Right now, there's no confirmed split in 3I Atlas. Its inner core still looks like one object. The strange, elongated, or peanut-like appearances could just be active regions lighting up different parts of the surface. They might not be separate pieces yet, but if this comet stays active this long, at this intensity, the risk only grows daily. Every new venting layer adds more torque to its spin, more internal pressure trying to crack the nucleus open, more thermal stress as parts heat and cool at different rates. This cosmic traveler is testing its limits. So what does the future hold for this cosmic enigma? If the activity finally tapers off in the next few updates, if the jets fade smoothly over the next week or two, and everything winds down as expected, then this alert will be just one more wild chapter in an already incredible story. It will be the tale of a damaged but intact interstellar visitor that survived a brutal pass near our sun and then sailed away to continue its journey through the galaxy. But if the activity keeps hanging on, if more shells keep appearing in the coma, if the tail structure keeps sharpening instead of fading, if that non-gravitational push refuses to drop off as it should, then we are entering completely uncharted cosmic territory. We are watching an object from another star system stay alive longer than our models predicted. We're watching it push itself harder than we thought possible on its way out, and nobody knows what this means. Nobody knows how long it can keep this up. Nobody knows if there's some incredible internal strength to this nucleus we haven't accounted for, or if we're just watching the slow build-up to something catastrophic. So the real question now isn't just whether 3I Atlas is still active. We know it is. NASA just confirmed it. The real question is, how long can it stay this active before something gives? How long can these jets keep firing? These layers keep waking up. This stress keeps building before the nucleus can't take it anymore. We are in a truly strange position, waiting for the next update, the next observations, the next alert, not knowing if it will say things are finally calming down, or if something even more extreme has just happened. Maybe we'll see its brightness finally dropping normally. Maybe the jets will switch off, or maybe we'll see new features appear. Perhaps that peanut shape will separate into distinct objects. Perhaps we'll watch this interstellar visitor fracture in real time. I can tell you right now, I'm checking for updates every single day because this is truly unprecedented. We've never had an interstellar comet stay active this long after perihelion. We've never had this much detailed data on an object from another star system. We are literally writing the textbook on interstellar comet behavior as this unfolds before our eyes. And what truly amazes me, what I keep coming back to, is that this comet has already survived a journey we can barely comprehend. It formed around another star. Who knows how many billions of years ago? It got kicked out of that system somehow. Maybe a gravitational interaction with a giant planet, or its star went through a violent phase. But something powerful threw it out into interstellar space, and then it simply drifted. 3I Atlas is a cosmic survivor, a silent witness to unimaginable eons of stellar history, still defying expectations.